notebooks. And so we're going to be trying to run through these using this kind of format. So essentially, it's a hybrid of Markdown, which is a kind of a presentation, HTML light, and then you have in each of the sections areas where you can actually run code. So it's a really cool tool. It's just, yeah, we're trying something different. So myself, I am Jeff Scripter. I currently work for Wells Fargo Bank with many of the people on this call. I've been an IT professional for about 15 years, and I am a little too into home automation sometimes. Adrian?
So my name is Adrian Rodriguez. The picture actually is not a picture of me. My Twitter profile is actually no big deal. It's a PSRDRGZ on Twitter. You can find my profile picture there. Much like Jeff, I work for Wells Fargo. I've been working with them for a little under a year now, but I've been in IT for about 10 years. As a side note, I am a part-time dog breeder of Golden Doodle dogs.
Okay, and so yeah, just a high level of like what we're going to touch on. So when Adrian and I were kind of going over different topics, we kind of brainstormed with a bunch of stuff, and being a little concerned that we were going to run a little short on time, we threw way too much in. So this might end up being a little too fast, unfortunately. But first topic is we're going to talk about different performance tricks that we've seen over like our careers, different ways that to look at how to find performance, and really just trying to show examples of how you can dig a little bit deeper and look for slightly different objects to actually increase your PowerShell script performances. Then we're going to jump into debugging. I know that that's one of, it sounds like a particularly dull topic, but actually using the PowerShell debugger is a fantastic tool and has some serious advantages over the interactive session and just like running lines of code to get to the point in your script where you need to debug. So we're going to go through some of those. And then lastly, we're going to kind of touch on some security tools and security topics. So hand it over to Adrian and we can get started.
So working at Wells Fargo is the first time I've really worked for a large organization. I found, when you work for a large organization, scalability is something that you really need to keep in mind, and the performance impacts that you might encounter when working at that scale. So below, just a few tips and tricks that we've encountered that you may find benefit in your shop. So just to go over some obvious stuff, measure command is your friend, generally speaking. So if you're not aware, there is a commandlet within PowerShell called measure command, which you can use to, evaluate how much time it takes to run a particular expression. There are multiple ways to, kind of performance test your scripts. Another way is using a stopwatch within your script to evaluate the timing, the performance. So just a few other things to keep in mind is that really the core of tuning your scripts for performance is really searching for alternative tooling and methods to find those performance solutions. Now, we have a lot of principles here down below. The thing to keep in mind is that they may or may not be effective in your shop. It really depends at what scale you are working with, whether or not you'll really gain much benefit from these tips. And the reason I say that is because you have to keep in mind your development time and supportability when tuning for performance. You could have a super performance script, but if it uses a lot of obscure .NET methods that not many people on your team are familiar with, you're obviously going to reduce the supportability and increase the development time. So to dive right into it, let's start with parallelism. So in PowerShell, there are a few different ways to, iterate over objects. You have the for each object commandlet. The previous for each is the statement. And then you have the for each method, which was introduced, I believe, in PowerShell version 4. Now, all of these have performance differences, which we can show you here. So if Jeff hits play, so as you can see, what we have set up is in these examples is just using each of the for each methodologies, iterating over just a set of numbers and seeing how long it takes. The big takeaway, as you can see here, is that for each, the statement is much more performant, and where possible, you should try to shift to using for each the statement. Right behind it, you have the method, which you can just do a dot for each on your array object, and that's not too bad. And quite a ways behind it is the for each object commandlet using the pipeline. In general, where possible, try to avoid the pipeline because you'll find there are significant performance degradations in there. So if you scroll down a little ways, Jeff, the one thing I do want to mention is that the for each object commandlet isn't all bad. They've really made it a lot better in PowerShell version 7. They now support parallelism with the -parallel parameter. And again, that's new to PowerShell version 7. It utilizes run spaces under the hood. Previously, there were lots of different ways to, utilize run spaces. There were some community modules, but this is now an officially Microsoft-supported way to use run spaces. The one thing to keep in mind, though, is that you really have to evaluate whether it's good for your solution, because of the spinning up of run spaces, it can increase your overhead. So depending on the task, you may actually find it reduces your performance. So just, play around with it and find out if it's actually a solution in your use case. So moving on, we have Invoke Command. So some people don't know, Invoke Command is inherently, it supports parallelism, but that's when you use it in a particular fashion. So below is some patterns that I've seen in certain scripts that you perhaps want to avoid. So as you can see in this example, we have a list of computer names. And what you really want to do when using Invoke Command, and especially when working with remote hosts, for instance, say a whole array of desktop PCs that you need to manage for some reason, you really want to run Invoke Command as shown in that first line there, or rather the third line. As opposed to right below it, you see that we're using a for each statement, and that effectively forces Invoke Command to run sequentially rather than in parallel, and that will have significant impacts on how long it's going to take for your script to run. So that if you have that anywhere, that's a quick win. Just replace how you're using it. So scrolling down, this is another big one, and this is important because it really highlights readability and supportability, development time versus the performance gains. So when creating arrays, there are multiple different ways to do it in PowerShell. The first of which is standard PowerShell ease, so to speak. As you can see, we created an array and we use the += assignment operator to add to that array. So that's the first method that we're going to evaluate. If we scroll down a ways, another way in which you can create an array is creating an array list object. And so as you can see, that's what's written there and highlighted. And then right below it, we have the add method for that array list, and we're casting it to void because it does output. And we're going to evaluate what sort of performance that has. Scrolling down a little ways, you'll see there's yet a third option that we can employ, which is creating a generic list. And that, similarly to an array list, has an add method, the difference being it doesn't have any output. But the downside with the generic list is that you do have to specify a type, the type of object that's expected to be in an array. And so that's why I have int specified, because in this example, I'm just using a set of integers. But say you have an array that is going to contain multiple different types of objects. Well, then you can just specify the parent class of object to kind of work around that. But let's see if it has any performance implications in our example here. And then lastly, well, not lastly, but second to lastly, with that generic list, there's also the ability to use the add range method. And that allows you to, bulk import a list of items into your array. Scrolling down, lastly, this is also more native PowerShell code, setting your array to the output of a for each statement. It's not my particular preference as far as the way it looks, but we'll see how performant it is. So if Jeff runs that, we'll see how the performance is.
Yeah, personally, that last one is a little hard for me to read. I don't usually think of for each as having an output.
So it'll take a little bit, iterating over a few 1,000 integers. But here soon enough, you'll see the results. And I can highlight the biggest result. As some of you may be aware, the standard PS array addition, that is the plus equals assignment operator, is by far the least performant option when it comes to creating and adding to arrays. So here's the results. Markedly different, markedly slower, many milliseconds. And then the rest of them are obviously so much quicker. And it's really up to you if you want to employ any of those methods, because as you can see, it does use some .NET classes, which depending on your team's skill set may decrease supportability. But what's nice, if you look at the pipeline method, that is to say, assigning the output of a for each statement to a variable, that actually is pretty performant. So it's something to consider if you want to stick to native PowerShell. Moving on, we're going to evaluate hash tables for fast lookup. Often when you're dealing with arrays, you need to extract from that array a particular item. And there are lots of different methods to do so, one of which is using either the where method or where object. Now, I chose the where method here in this first example because that is much quicker than using the pipeline and using the where object commandlet. I don't have that highlighted in this particular example, but just keep that in mind, the where method faster than the where object commandlet. Again, pipeline in general will slow you down. But as a second example, what I have here is a hash table filter. So what we're doing here is we are creating an empty hash table, and then we're iterating over each item in our array, and we're adding it to the hash table such that there's a key and pair, and then we're using the key to extract whatever item it is we're after. And so the easiest way to do that is just dot whatever the key is. And so I think Jeff ran that, and so you'll see the results right below. The hash table filter, as you can see, is quite a bit faster than using the where method. And I wish I would have included it, but the where object commandlet is even slower yet still. So that's one method you can employ if you're trying to, select items from an array. But as you can see, there's a little bit more code there. So it may, again, reduce the readability and supportability of that solution. So just mess around with it.
And I just wanted to highlight something else here. So when you're doing the add here, this first parameter is actually going to be the key, and that key needs to be unique. So if you're doing something like comparing two directories, you might want to use something like the full path or the full name in the key, and then you'll be able to loop through your second directory and very quickly check, is this path similar? Or the idea is basically just make sure that the uniqueness is there in whatever property you're searching for. Okay.
Well said, Jeff. Thank you. So here I do want to highlight that when we're writing our scripts, we should really only pull back from remote sources, even local sources, only the data that we need for our scripting. So as an example here, we're running get_some_instance to look at all the Win32 services. Perhaps later in my script, I am doing something with those services. Maybe I just want to know what services are running on a computer. Running it just in that first example as is, get_some_instance Win32 service, is all fine and dandy, but what we can do is add the -property parameter and specify the properties that we're after. And since all I really aim to do is list the services that are running on this computer, that exist on this computer rather, I can just specify that one name property. So if you scroll down a little ways, you'll see that with regards to performance, specifying just the data that we're after has quite a bit of performance gains. So here's a big example that's really kind of hard to highlight the different ways in which you can do this. And really what you aim to do is reduce the number of network calls you're making. Try to batch as best possible all your processing such that you're only making as many network calls as you need to. So for example, what I have here is a remote computer. We'll call it a desktop PC001. And what I aim to do is, get the services, processes, and computer info from this device. And perhaps I'm going to export that to a CSV for management to review. There are multiple different ways to do this, one of which that I've seen is just as shown in that first example, calling Invoke Command, getting the services, saving that to a variable, getting the processes on that remote computer using Invoke Command, saving that to a variable, and doing the same with computer info. And then thereafter, once I have all of that collected, then creating a PS custom object on my local computer. The downside with that is that we're making 3 network calls, where as you can see in that next example, all we really need is 1. We can make all those same function calls using get service, using get processing, using get computer info on the remote host in one fell swoop with 1 connection. And that will save you a bit of time. But this can come into play if you're working with Active Directory. Rather than making repeated calls, make one big call to get for instance, say you're working with a list of users, rather than iterate over a list and call AD each and every item in that list, you could just make one big call, save it to a variable, and then extract the values that you need from that. So really, it's more so a change in the methodology you employ, but it can make quite a bit of difference with regard to performance. So the next section we're looking at just filtering left. A lot of people who've used PowerShell for a long time know that it's very necessary to filter left. And what that means is PowerShell employs the pipeline, and you can make use of the pipeline to do a lot of filtering or iterating over items. But the downside, the pipeline, does have some performance downsides. So in this first example here, we're just running a get child item. And really all we're after are those items that start with L. So in this first example, in order to obtain that data, I'm using where object and doing the filter on the right. But on the second example, what I'm using is the filtering that's already inherent to get child item that's built right in. So I'm filtering left. So as you can see, there is quite a bit of performance to be gained back from filtering left. And in general, that you can find performance gains in all sorts of ways using all sorts of commandlets. Now, here's one that not a lot of people are readily aware of. I know I wasn't. And that's to avoid error action silently continue, or rather, another way to phrase it is check first. So a lot of PowerShell functions allow you to, silently continue if an error arises. But the downside with doing that is that it does have performance downsides. So in this first example, I'm just iterating, over some numbers and removing those files from my computer. But I'm using error action silently continue rather than doing any sort of error handling. Perhaps I don't think it's necessary for one reason or another. In the second example, though, what I'm doing is I'm doing the same thing, but first I'm checking with an if statement to see if that file exists. There's a lot of different ways to do that. I could have used test path, that commandlet, but here I'm using system.io file and the exists method of that. But I'm checking first. And so as you look at the results, by checking first, I gain some performance back. It's a little counterintuitive because I added extra code, which is doing extra stuff. But when you use error action silently continue, it has to save that exception to the error variable. And that does, incur some overhead, which can impact your performance. So if you scroll down a little ways, lastly, the only thing I want to touch on, and this is just one example, is consider using .NET, especially if you're doing any development, on Windows itself. So there's a lot of ways to do things natively in PowerShell. As an example here, I have just creating a very long string. So I have a null string, and then I'm just adding Z to that string 100,000 times using the native plus equals assignment operator. But in the second example, instead of using native PowerShell, I'm using the system.text.string builder class. And I'm using the append method on that to create the same string. And as you can see, if you scroll down a little bit, there's a big performance difference. So depending on your team, depending again on development time and supportability versus performance, it is something to consider looking at .NET classes to get back some performance. And it's really not just .NET classes. It's really looking, as said in the very beginning of this conversation, look at alternative methods which may give you better performance, whether that's using rather than using the PowerShell function that was provided by the vendor, using their API directly. Perhaps they do some validation that doesn't necessarily need to be done in your environment. And by skipping that validation, you get some performance back. So just look at alternative methods where possible. But again, always keep in mind development time and supportability versus those performance gains. And I think that's all I have to say.
Yeah, we can open it up for a few quick questions if there are quick questions. Otherwise, we can move on. Okay, moving on. So
everyone's itching to hear you debug.
Exactly. It's an exciting topic, I know. So what are the key benefits to the debugger versus just running your script line by line and interacting with it with an interactive console? Well, first of all, depending upon how you use the debugger, you can actually see a list of all of the different variables in your script as the script is running. So it's really good to be able to quickly sort through different variables and see if anything is kind of out of place. You can also very easily stop at a very specific point in your script. If you have a 100-line script or longer and you need to get to somewhere in the midpoint or towards the end of it, running through every one of those lines interactively can waste a lot of time. It's a lot easier to just set a breakpoint and be able to run the script and let it stop at a specific point. And then one of the last big updates is you can dive into different contexts that you are a little bit more difficult to get into to troubleshoot. An example of that is a module context. So if you have a custom written function and you need to debug into that, it can be a little bit tricky to set up all the variables and stuff for that particular function. But with debugging, you can just break at that point. So let's go ahead and take a look at it. So here's an example of some code or see pretty frequently. So if we just set our location, we load a module, we want to loop 3 times or 10 times, but stop at the third loop for some reason, some condition happens, but instead of using the -eq, we use the dash or just a straight equal sign. If we run this, you can actually see it actually does execute just fine, but we don't ever see any of our output. It just breaks unexpectedly. So this might be an example. You're coding a little too fast and you don't quite see where your error is. And so you know it's somewhere in your loop. So we add the wait debugger. And the wait in a bunch of different. You can use it even in a standard interactive console. So if we run this, it will loop through and it hits that wait debugger and immediately jumps and says, the next thing I'm going to do is run this particular line. It squiggles for you. And so if we need, we can look at put H in. That gives you a list of all the commands that we might need to have to see. We can then proceed to step over, which is going to be V, and we can just keep seeing it. It's here we have we immediately broke into it, and we can actually set to 3 here. So being able to set that wait debugger on any of your scripts and immediately jump into your script at that point is really, really handy. So let's go and let's fix this so that it operates correctly. And let's say that the problem is actually in this user-defined sleep function. So let's go ahead and grab a script block. We're going to use the interactive session in my VS Code here. So now we've jumped into the script itself, and you can start to see some of the benefits of this. So if we next with an interactive console, you're actually going to have PowerShell prompt you with the script or code block being run. And you can actually get easy use commands here. We can jump through things and get to the point that we need. And this is where we have all of those variables that we might possibly be interested in just automatically displayed for us. And we can just scroll through and see if anything's out of the ordinary. But now we're also at this start UDF sleep. And if I want to see what's going on inside of that function, assuming it's a PowerShell defined function, we can just step into it. And once we step into it, it brings up the code that is used for that function. So this is what separates it from just an interactive session. You have a lot more control and a lot more ability to kind of jump into different pieces and troubleshoot exactly what you need without as much setup. So let's get back to this. So you'll also start to notice that I'm running these code blocks in ways that might be a little bit difficult to actually interact with as well. So using Invoke Command, we have a script block, or using a script block with a .invoke method. That's usually a little bit tricky to interact with. But with the wait debugger, sees that you're executing that, stops at the exact point that you want it to stop at, and you're good to go. So if you're trying to say use an invoke command, and you know something about this line is throwing an error or something like that, you can actually set a condition and then just add the wait debugger and it might loop through 10 different runs of this script block, but once it does throw that error, then your debugger catches. So you can be really clever with how you use this, and it can be a fantastic tool. So the next thing I'm going to show you is how to set up your VS Code to use the debugger. So as you can see here, we have the little bug that's sitting on top of the play button in VS Code. If we want to set this up so that we can write a script and then use the debugger right away, what we have to do is we have to first create the JSON. If we click on PowerShell and then we say, let's go ahead and launch whatever file I am currently seeing in the editor, that's going to generate the configuration of it. And then now we have our configuration set up to run in that particular method. So as you can see, we have a PowerShell launch current file. So what does that mean? If we go to a script file here, we can then click on and set a breakpoint at that particular at the particular line that we want to break it at. We don't have to use the wait-debugger anymore. When we're using an integrated console, or when we're using a proper IDE for this, we can just set breakpoints directly in our scripts. And if we want, we can disable them, enable them, do whatever we want. But then when we click play, it's going to loop through and stop at the exact point that we want. And we have the same abilities to just jump into it. So you don't actually even have to edit your code in order to use the debugger, assuming you're using either the ISE or better, hopefully you're using VS Code. So now we get it. We're going to move on to the trickier topic. So the next logical step is, that's great, but what happens when I can't connect to one of those, whatever I'm testing? Say you have a CI running in Config Manager on a system remotely, and it's erroring for some reason, but it works perfectly locally. Or you have a scheduled task running as a service account or something along those lines. Remote debugging is the next step of that. So will allow me to use admin stuff. Tell me if you guys can see the prompts that I just launched. Can you guys see the PS exec section here?
Yeah. Who am I?
Awesome. So you can see running PS exec, I've got my session. So let's jump into PowerShell. So this is going to be just like either a scheduled task or maybe CM is running this. What you can do is you can, I am going to set the location to where I have all of my tooling and stuff like that. I'm going to write a file it could be a network share, it could be my local, a local disk or something like that, but I need to collect certain pieces of information. I need to collect the computer name, the process ID that I am operating under, and then the run space ID. This is the thread that you're actually executing your CM code in or whatever it might be. And I'm just writing that to a file. And then I sit in a wait. I'm just running some other code. I'm looping and just kind of doing what I can to wait until I actually connect into something. So now we're running our code. We've made our file. We're sitting in a loop, just kind of waiting for me to connect to it. And I'll share this code with Greg and the other leaders so that they can distribute it so that you guys can play around with this. So now the next step is I need to connect to that. So I'm going to take this information. I'm going to do the same thing. I'm connecting in to get access to my module and stuff like that. I am setting up where the file path is. Nope, never mind. I may have overridden that piece. Nope, never mind. Here we go. So if I need to enter into the PowerShell session, we're just going to take that same file. We are going to get the contents. Since it was in a JSON format, I'm converting it out to JSON. If it's remote, we do an enter PS session. That PS session then allows us to connect to the remote system to execute commands on it. We then use the enter PS host process that will bind to the process that's running, that process ID that we just collected in the previous script. And then once we are on that process, we actually can enter the debug state. Since this is local, we're going to do things a little bit differently. So let's go ahead and run some of these commands. Awesome. I now have my my data. If you want to take a look at that. And so let's go ahead and connect to that process. We get an error. This is the thing that makes me least concerned about this process. I've had a teammate that was really concerned that this was a security vulnerability. In order to connect into a PS host process, you either need to be an administrator on the box or the same user as the process that the process is running under. So there are some security things in place to make sure that nothing happens, I guess. Let's launch something as administrator. I'm going to jump into the ISC since we haven't given love to the ISC. It hasn't been updated in a long time. We're going to run the same code. So let's go ahead and select all the way down, copy, paste, and let's go ahead and run this. So you can see that currently I'm running under this user account. I'm now bound to the process. And if I do who am I now, you can see that I am system account. So I'm connected to the process, but if I get run space, you can see that, come on, you can run. Oh, come on. You can see that what it did is it actually just made another run space for me to connect to. So what I need to do is enter the other run space. And so what I do is I just debug that specific run space. I know it's run space 1. And let's see if this demo goes particularly well or not. Sometimes attaching to this, because there's so many moving parts, it can be a little bit hit or miss. So I'm going to try that again. Might have to retry this. Cancel here. See if we oh, never mind. So you can see that it's now connected. I am running under run space 1. I am connected to that process. And again, if I can do all of the same commands as before. So we can see L will list out what the function is that I'm connecting to and running and executing with. We can, go run to the next step. We can do a bunch of different things. And it looks like my breaking of that process up here may have disconnected. But this is a particularly powerful tool when you need to enter into another context. All you need to do is add that add the steps where you're looping through something and waiting for the debugger to attach, and then make sure that you're actually an admin. And then you can attach to it, and you can debug your specific script in the correct context. So it's one of my favorite little tricks. And if you talk to my coworkers, they'll tell you that I probably go a little bit too far with the debugger sometimes. If you are, however, concerned about security, you can actually go and set the debug mode to none, and then nothing can attach, period. So if you have some compliance thing running and you need to ensure that nobody is tinkering with that run space, the first line of your script could just be this host process, get the run space, tell the debugger to set to none, and then nothing can connect to it from that point on. So I'm going to stop for a few questions here. It was really quick. We covered a lot of ground with this. So are there any questions about the demo? Can people still hear me?
Yes.
Okay. Then I guess we'll move on to the security side of things. So let's talk about the obvious stuff first. I've been at companies where they did not decide to set permissions on shares and folders correctly for where they're keeping scripting solutions and stuff. If you don't lock down where you're keeping your scripts, if there are any secrets in there, they can be leaked. Otherwise, potentially somebody could be editing them. So just this is the obligatory. Make sure you're using permissions correctly with your stuff. The second kind of obvious stuff is I'm sure everyone here has heard, be careful with code injection. Code injection happens across multiple languages and can happen in ways that you don't necessarily expect. So here's an example where we're just going to load, we're just prompting for a specific file dialog. And so with this file dialog, you can very easily, type in CMD at the top and it launches the command prompt. So if you are running something as admin, or under the system account, but it prompts the user for a file location for something. Maybe you're doing a user state migration. Somebody can use those tools to get into a command prompt. So that's the general idea behind code injection. And there's a lot of different ways to do code injection. If you're concerned about your PowerShell script having code injection, there's the injection hunter module that is out there that you can scan your script and see if there are any obvious injection points. Otherwise, you can always use the secure code generation API that is built into PowerShell. So the way that works is, say we have a script, we prompt for a user input, we're then just going to write that input to the verbose log. Well, if you format it correctly, you can end the quote, use the semicolon to start a new statement, execute whatever malicious code you want, and then end the statement, and then complete any potential other errors that you might have. And so you can kind of see if you have the raw code, if we were to just use invoke expression against this would work just fine. There's no errors. It's going to write output to the verbose log, and then it executes the malicious code just fine, throws no errors, and there's no way to necessarily know. If you use the secure code generation API, you have a bunch of different methods for escaping out known attack methods. And so you can kind of see it double quoted all of the single quotes. So at this point, if we were to execute this, it's no longer a valid statement, and so it actually will throw. So this is another way to help mitigate code injection if you need, but there's a lot of different types of code injection, and there's a lot of different ways around it. So just something to be aware of, but there are good tools for dealing with it. The other thing that I feel like not enough people know about is over-the-shoulder logging. So there are a couple of ways that your system is presenting data that you might not know, and you might think that you're correctly operating something in a secure manner, but it's not. So if we were to go ahead and run this script, I'm going to give myself just a hair more time than 15 seconds. If we run this, this is just a PowerShell command. We pass in a username and password. So now if we go to the task manager, you can actually add the command line by just selecting select column and adding the command line. And you can actually see we actually have the decrypted username and password. And I've seen a lot of good IT pros do this, sometimes just out of laziness, sometimes they just genuinely don't know. But command lines are accessible. So just because you're doing it correctly in your script doesn't mean other people can't see it. And then the other big one, and this one's a little bit worse because this actually does save. So if we have a username and password, we convert that password to a secure string or something like that. and then we save it to a credential variable, we can actually go and see viewer over-the-shoulder logging might be logging those passwords and those commands, even if you don't necessarily think that it should be logging that. So in our current example, the password is being passed in to this commandlet. This looks like a secure method for doing this, but with over-the-shoulder logging, it actually does expand the variable in the log. And so you can take a look at it, and if my event log will ever load, there we go. We can just kind of step through some of these things. Here's the commandlet specifically, and if we look towards the bottom, we have our parameter binding, and we can see our password clear in clear text. So really, you should be working with your security to make sure that this particular event log is actually locked down so that people can't view it. Because by default, a lot of people can view it that should not be able to view the PowerShell event log. So moving on to secrets, PowerShell has released the PowerShell secrets management module. The idea behind this is they wanted to give some standard commandlets to admins so that they can store secrets in whatever backend secrets management tool they want. By default, it uses this local secret store, and it is an encrypted file that is encrypted with a password that's prompted to you. If you want, you could set the configuration so that you aren't prompted every time you try to set or retrieve a password from the vault. But we can see that it's pretty simple to use. And these are all you really need to do to set it up. You install the module from the PS Gallery. You then register a secrets vault, and then reset is if you just want to pave over it and you forgot the vault's password or something. Set configuration sets your timeout, and if you want the user to be prompted. But once you get to this point, you can get the password back from the vault. It can be a little bit trickier, unsecure if you're trying to execute this like through a script. And so it has some great implications. It might be more stores might be added in the future. For now, the only stores I know of are the local store and the credential management, the Windows-based credential management module. So hopefully that gets better in the future. We will see how that kind of goes, but it's an option out there if you need. If you want to roll your own secrets management stuff, there's a couple different options you've got. The general idea behind this is that when you're taking some kind of a secret, you are going to encrypt it, and then you're going to have something else that needs to be stored securely. And so anytime you're trying to run something non-interactively, you need to have all of the pieces available at the time of execution. And so when I say security is never perfect, it assumes that like all the pieces are there somewhere on the system. If I memorize the key that I use to encrypt something with, then yeah, it's a pretty secure solution, but then I have to be there every time I'm running and executing something. Where if I have the pieces there, you're going to want to separate those pieces as best you can, either behind permissions or through different delivery methods. So you have the encrypted payload as part of some kind of an INI file or some kind of a config file, and then the key to decrypt it is passed in through, it is either retrieved from a safe location or passed in some other way. So separating those is going to be the big concern with some of this. Since we're running a little bit behind on time, I'm going to kind of gloss over the group managed service accounts. The idea behind this is that Active Directory is going to manage the password for you. There are some significant limitations to this where usually the account has to be installed on whatever system you're running the solution on. So this is good for scheduled tasks, but if you're trying to run something through CM, this is not the solution for you. But if you want to know more about it, my colleague Ryan F. Grave has a good blog post on the different ways to set it up and the different ways to kind of hack it to make it a little bit more of a flexible solution. But I included some basic command lines here for if you guys are interested in kind of playing around with GMSA accounts. The next one is probably going to be a little bit controversial, the data protection API. So data protection API is a subsystem built into Windows. The way that it works is you have a bunch of keys that are actually encrypted on your local profile. So if you look at app data roaming, you can see there's the cred hist, and then you have the SID for the user, and you have all of these keys. These keys are randomly generated by the system and then encrypted with whatever current credential you are logged in with. And so the process for decrypting DPAPI stuff is going to be you take the payload of whatever you're encrypting, and then you have to decrypt the protector here, or decrypt the key here with what the user's credential. And so that sounds really complicated. The thing is that since it's a very standard process, and usually you're logged in either under interactive, like you've just logged into the computer, or you've logged in through some other method, you have the credential already there through an integrated session. And so it ends up being a very, very easy encryption system to use. And so Windows uses it a lot. A lot of your browser secrets, biometric data, the credential manager, depending upon how you've set up like Wi-Fi stuff, you have your Wi-Fi passwords in this format. The downside is, again, if you can get into the user's context or get the user's password or credentials and keys, you can decrypt this stuff. So if we run this, this is how you're going to go about creating the credentials. So we have our secret. So it's just password 123. We first convert it to a secure string, and then we can use convert from secure string to use the DPAPI and actually get this kind of encrypted payload. And this is what you would end up saving locally on the box. And with this, you can then kind of step back and use it in your scripts or scheduled tasks or something like that. And the process for decrypting it is pretty simple too. You take the payload, you use the same convert to secure string, and then you can just build a credential object, or you can use it directly. And so if we run it here, we can see we successfully made a credential object, as well as we got the password out. So the benefits are that it is very easy to use. The downside is that you really have to do your due diligence to make sure that that session is secure. If you need to go and pass a secret to more than one box, so DPAPI, there are some caveats to it, but for the most part, it is per user, per box. If those requirements are not good for your solution, if you're passing something through CM, symmetric encryption is another option. And so this is going to be pretty similar, but instead of having the key saved locally on your box, close that, you actually just give it a key. So in this case, I am providing a passphrase. I then take the passphrase and I convert it to bytes, and then I take the hash of that. And that hash is the actual key that is used to encrypt and decrypt data. And so you could have one script there to create this encrypted payload and then save this payload in a CM package or something like that. And then as long as that key is available, maybe you pass it down through a CM variable and you pull it out of the WMI. Maybe you just you want to keep it simple and you use an argument to your script and you pass in the key phrase to your script. However you want to do it, as long as those two pieces are separated, it's a pretty decent solution. And so you can see we take this payload, we take the same key as before, and then we can actually, again, convert the whole thing to a secure string. And then here's the .NET approach to reversing the secure string and getting the clear text out of it. So yeah, it's the biggest caveat with this is protecting the key. But as long as you think through that process, this is a good way to approach it. If you have concerns about this, obviously talking with your blue team, if you have a blue team, so to get their thoughts on it might be a good idea as well. Hopefully your blue team will not just say no and will come back with suggestions. And then the last thing I'll touch on is code signing. So code signing, what it does is it provides you a mechanism to ensure that your scripts have not changed. So the process of signing something is it takes the whatever file you're signing, takes the hash of that, and then it encrypts the hash with the private key, the code signing key. And then you have an encrypted hash. But the way to decrypt a PKI key is using the public key, and that is attached to it. So if we actually kind of run this, you'll see, let me go and open up my signed file. Okay. It's here. There we go. Now we can sign it, and right. So since I didn't trust the key that I just made, I can't actually execute it, but we can actually go and look at the signature block, and you'll notice that it's pretty long. The reason is that this signature block contains the key information of the public key used to sign it. So if we look at the file itself, let's reveal it. We should be able to see the certificate, the public key. And so you can, because that is embedded in there, it knows it's got the encrypted hash as well as the key that's used to decrypt it. And then you can hash the file and compare what was there when it was signed with what you have determined to be the hash. So that's the idea behind it. It can be a good solution, but it needs to be partnered with other policies. You shouldn't be able to just delete the that information, the key part, and then run it. You need to have the execution policy and other things set up to enforce that. So, but it might be a solution for some of your code. So that is our demo and our presentation. Are there any questions?
All silent. This is really good, guys. I really appreciate it.